Okay, I want to do this recording, right? So that you can actually learn on your own. Basically, this is actually the solution given for the worksheets that I have already given to you. So let's look at this first question. You can see that you have your solid potassium hydroxide with 4 moles of water, and basically this is actually a water of crystallization, and you dissolve them to make up to 250 cm cube of aqueous solution, and then you label it as Fa1. You take this Fa1 20 cm cube out, and then after you dilute to 100 cm cube, and then you label it Fa2. Basically, right, it's a bit boliao. But anyway, this is a question, so you just follow. First, you just need to calculate the concentration of KOH in Fa1. So you know the idea of concentration, right, is always taking the number of moles divided by the volume in dm cube. Okay, but of course, the trap here in this case is that the amount of KOH, right, okay, when you take the mass of the KOH with 4 moles of water, right, please remember to divide by or include the 4 moles of water in your MR. Okay, so you can see from the answer, there's actually 4 times 18.0, and it's because they have taken in water into considerations. Okay. Of course, the number of moles of the KOH here and with KOH basically is the same. To calculate the concentration of KOH, basically just can take the amount that you have calculated divided by the volume. Okay, remember the question was 250, so make up to 250 and you divide by 250 over 1,000. Do remember that you are looking at volume in dm cube. So just to do a recap, concentration is taken as mole divided by the volume. Okay, very simple. So that's part A answer. Let's go through part B. Basically, part B, you can see that you do a dilution, and of course, the dilution is basically a 5 times dilution. And in this case, you are supposed to calculate the new concentration. Okay, so what you can do is, since it's a 5 times dilution, you can just divide by 5. Okay, how do I know it's a 5 times dilution? Because you can see that you have convert the volume from 20 to 100. Okay, so that's a 5 times dilution. But of course, if you are not, if you do not want to do that, you basically can use this formula. Basically, this formula is very simple. C1V1 is equal to C2V2, because if you take concentration times volume, the amount of the KOH remains the same. The amount of KOH remains the same despite the volume used. No matter how you dilute, the amount remains the same. It is the concentration that changes. So in this case, you can use this formula and calculate the new concentration at the end of the day. Okay, that's B. Finally, C, right? Okay, you can see that now they want you to use the super diluted Fa2 to do some calculations with H2SO4. So imagine if you are not able to get A and B right? Obviously, your C will be wrong. So that is quite a challenge. I believe in IB, sooner or later they'll do that. So that's why we need to make sure that the foundations we had is strong so that we are able to do A and B. Okay, so if you look at C, right, again, some students will ask whether is this equation important. I would say yes. Okay, balancing this equation is the basic. As you know that acids and base always give you salt and water. And of course, to balance this equation, you need to know how to balance the chemical internally correctly first. What do you mean by balance the equation internally correctly? Basically, that means that the formula of the chemical must be correct. If you do not know that potassium sulfate is K2SO4, then obviously that is a big challenge. And obviously, you know why it is K2SO4, because SO4 it's a 2- and K is a K+, so that means that the formula of potassium sulfate will be K2SO4. Okay, now knowing that there's a 2 here, that means that you need to put a 2 in the KOH, so to balance the K on both sides. And of course, you know that in acid-base, you always produce salt and water is produced, and you have 2 moles of water. How do I know there's 2 moles of water? You can see on the left-hand side, you do have 2H and 2H, total 4H, therefore 2 moles of water is produced. So that balance equation is very important. Then after, you are supposed to calculate the amount of H2SO4, and of course, H2SO4, in this case, you can see that basically this is how you calculate the amount, C times V. Okay, and of course, this will be the mole. And then by mole ratio, you will realize that this is KOH is basically 2 times as much as your H2SO4. Basically, just multiply by 2 and you get the amount of KOH. Okay. Very simple. And then after that, knowing that this is the amount that you need and you are given the concentration, you can happily work out the volume. Okay, I forgot to put the hint here. To calculate the volume, you take what? You take mole divided by concentration, right? Mole divided by concentration, you get the volume in dm cube, and make sure that you multiply by 1,000 to get the answer in cm cube. Okay, so all these are important mole relationship that we need to know, and obviously these are the typical questions that will appear in most of our tests. Okay, then after that, this is surely one of the most popular questions in IB, even in A-level. And of course, this question is good because it talks about how you can calculate the empirical formula given the composition by mass of carbon, hydrogen, and oxygen. And by the way, ascorbic acid is made up of carbon, hydrogen, and oxygen. Okay, so this is basically the most primitive way of asking. I do have another set of questions where they do not give you the mass of carbon, hydrogen, and oxygen, which I already discussed with you in the previous lesson. In this case, we are only looking at a very basic kind of calculations where you're given carbon, hydrogen, and oxygen. And of course, the question is to work out the molecular formula. Okay, given the molecular mass is 176. So before you can work out the molecular formula, obviously you need to work out the empirical formula. So that's actually one challenge in these questions, where they skip the step of asking you what is the empirical formula. So how to calculate the empirical formula? I believe you have learned this in IG, in O-level, in IP, where you're supposed to work out this table, where you're supposed to give us the mass of carbon, hydrogen, and oxygen. Okay, in this case, the percentage by mass is basically the mass, and the mass of carbon is 40.9, hydrogen is 4.54, and oxygen will be 54.5. Then what you need to do is to convert everything to mole, and you divide by its respective AR, and you get the mole ratio. And always remember to divide by the smallest number of mole, which is the 3.408, where you get 1:1.33 and is to 1. Okay, so this is a very good question because some students will round down 1.33 to 1. In this case, this is not allowed in IB or in A-level. We always take note that 1.33 is a very sensitive number. You actually can multiply by 3 to get a number 4 because it's 1/1/3. If you multiply by 3, you get 3:4:3. So that's the reason why you need to keep it as 4/3 or 1.33. If you do see 1.33, take note that you can multiply by 3 and can get a number 4, and the rest will become 3. So the empirical formula of ascorbic acid will be C3H4O3. So this is actually a very good question. Take note of the empirical is C3H4O3. Now, if you look at the molecular formula, as you can see, you're given the molecular mass in the question where the molecular mass is 176. Knowing that empirical formula is C3H4O3, basically it means that N times empirical formula will give you the molecular mass or the molecular formula. So from there, you're able to work out, it's just math, and you can able to work out your N where N equals to 2. Okay, so that is how you worked out the molecular formula in the empirical kind of questions. And obviously, you can see this part, right? Let's just go back to the questions again. What do they ask? After you have calculated the molecular formula, then they say, oh, you're supposed to titrate, right? So after that, okay, you can see that you have a 750 ml bottle. You take out 25 and you titrate against this concentration of sodium hydroxide. Okay, and of course, the volume of sodium hydroxide used for complete neutralization is this. So it's very simple. Always take C times V to work out, right? So you just take C times V to work out your amount of NaOH. And knowing that this ascorbic acid, okay, by the way, I think the question did mention that this guy is a monoprotic acid. Yeah, it is. Okay, basically means, what do you mean by a monoprotic or monobasic acid, right? It basically means that this acid is like HCl, it's like HNO3, where they react with NaOH in a mole ratio of 1:1. 1:1. Okay, so that's why this part is very important. You can see that once you have worked out the amount of the sodium hydroxide, knowing that this acid is monoprotic, you are able to work out the amount of ascorbic acid used, which is the same amount. And of course, now because you know that your titration value, you pipetted 25.0 cm³ of juice, you divide by the volume, you get the concentration. So that's how you calculate the concentration of ascorbic acid. Okay, very simple. Now, the next part, right, where I remember it was about the calculations of the amount of ascorbic acid in 750 ml. If you already know the concentration, right, what you just need to do is to multiply by the volume, okay, and then you get the amount. And after that, if you want to multiply by the MR, you're able to get a mass, okay? So basically, this part is basically more concept. So again, I tell you that this part allow you to work out the concentration. The total volume of the juice is basically 750. You multiply by the volume, you get the amount, and multiply by the MR, you get the mass. Okay, very simple. Okay, this question is not hard. Okay, basically it's for you to calculate the percentage purity through a direct titration. Okay, how do you know whether is it back or direct, right? So basically you just need to read the questions lah, huh? So if you look at these questions, right, you can see that you have 1.65 grams of impure sodium carbonate, and obviously the formula of sodium carbonate, by now you should know that it is Na2CO3. Okay, so basically then they say, oh, once you have make up into a solution, you take out 25 cm³ and you titrate with HCl. So basically it's just titrating sodium carbonate with HCl. So they did not react with excess amount of HCl. It's not a back titration, it's a direct titration. And you know the amount of HCl actually used. But what I know, right, in some of the students, in most of the time when you look at their test paper, right, students actually take 1.65 and divide by an MR of sodium carbonate, and they start the story with this and everything will be wrong. Because you must understand that sometimes the question did mention that it's impure. Some lousy question don't even tell you it's impure, and I feel that it's dumb. So, but then in this case, they did mention that this is impure. You are not allowed to use this mass to calculate the number of moles of sodium carbonate. Okay, Ken? So what can I do is basically, I know that this amount of sodium carbonate will dissolve in water and it will react with a HCl. So what I need to do, right, is to work out the amount of HCl through titration. So you can see the volume and the concentration is given. Let's say you are really like so blur, right, in the exam. What you can do, right, is to score, right, is always remember to take the last data from the statement where it always gives you the first answer for the questions. If they ask you to calculate the amount, can you see that? The last data is always the answer for the first questions. The amount of HCl required for neutralization, just remember to calculate C times V, divide by volume in divide by 1000 instead of cm³. So that's why you calculate C times V in dm³ and you get this amount. And obviously, this is very, very important. If you do not know how to balance this, yes, then you need to practice how to balance a carbonate with an acid. So basically, you can see that in IB, right, they want you to understand all the chemical equations between acids and carbonate, acids and base. All these are basic equations that we need to know. Okay, so these balance equations, and of course, based on mole ratio, knowing that the mole ratio of sodium carbonate and HCl is 1:2, and therefore you require less, and that's why you halve this 2.9 to 8 times 10 power minus 3. This will be the amount of sodium carbonate. And of course, if you divide by the volume, in this case, the volume you use is 25 cm³. That's how you calculate the concentration. Okay. And of course, this is the concentration. What you can do is you multiply by 250, you can get the amount of sodium carbonate in 250. Okay, if not, what you can do is you can base on the mass that you have calculated here or the amount that you have calculated here in 25. Okay, so this part is scaling. If you want to do it this way, it's possible. That means that if it's 250, that means it's 10 times more, and that's why you multiply this by 10. Okay, and then from there, you're able to work out the mass by multiplying the MR, and you get a mass of 1.552. And to calculate the percentage purity, what you can do is you take the pure mass of sodium carbonate. Now you divide by the mass of sodium carbonate, which is the impure, and you multiply by 100%, you get the percentage purity. So this question is important because it basically guides us how to calculate the percentage purity of sodium carbonate. Just take note that this mass that you see is not the mass of the pure sodium carbonate. It basically is the impure mass. So through this titration, right, you're able to work out the mass of pure sodium carbonate. Okay, easy. Okay, and then of course you look at the last one, which is your back titration. Definitely going to come out in most of the tests. Of course, back titration, I tell you 1000 times. The whole idea, right, is to titrate something that is unstable, which in this case, they're referring to ammonium chloride. And obviously, this ammonium chloride in the solution or in the fertilizer can be titrated against sodium hydroxide. And of course, it produces ammonia. But in this case, the ammonia is a gas, so it'll be driven off. So it's not the ammonia that will react with HCl, but it is the remaining NaOH that you have added in that will titrate against your HCl. So take note that the resulting solution is not the ammonia, but the sodium hydroxide. Okay, can? So obviously, some school will ask you to write the two equation, but actually what is more important is back titration always work from the back. So the back part, which gives you the first information, is the amount of HCl that is reacted with the remaining NaOH. Okay, so you work this out, and obviously you can see that this is the amount of NaOH. Okay, easy. And of course, it is very important to know the known and excess amount of NaOH used at the start, where it's also given in the questions where you use 50 cm cube and 0.216 concentration of your sodium hydroxide at the start. So that is actually your known and excess amount, which you have calculated in terms of mole here. Then after, what you need to do, right, is you know that if you have added so much, and then after that, this thing has gone into the solution with ammonium chloride, and that means that there's some chemical reactions, you are left with this much. That means that the difference will definitely be the NaOH that have reacted with ammonium chloride. So that's why the reaction 1 equation become important, because they're trying to show you that this amount of HCl, the difference, will be the amount that the ammonium chloride that you have reacted with the sodium hydroxide. So if you take the difference, right, this will be the amount of ammonia. Wrong, the amount of sodium hydroxide that reacted with your ammonium chloride. So this will be the amount. So that's why we always take the difference. Okay. So for back titration, right, always take the difference. Then knowing that this ammonium chloride, this N, okay, is the same as the nitrogen in the fertilizer. So what I can do is I can take the amount and calculate the amount of N in the fertilizer. And of course, the mass of nitrogen in the fertilizer is just 14. So you can just multiply by 14 to get the mass of nitrogen in the fertilizer, and then there's the mass of the fertilizer. Then what you can do is you just take mass of nitrogen divided by the fertilizer, multiply by 100%, that gives you the percentage of N in the fertilizer. Okay, so this, I hope this will help at least in your revision. Thank you.